So let's think about if we in lab we were given a solution, maybe it was a solution of rainwater or it was a solution from some acid mine drainage, and we were told we needed to know what the content of acid was in the solution. And so the way we would do this would be by a titration. And a titration means that we take our unknown solution here, and then in a burette we dropwise add an amount of base in order to neutralize this reaction. And so what does a typical titration question look like? Well, in your textbook you have an example of example 14.21, and I'm going to go through this example because they missed some pieces out, and there's one way of doing it and there's a second way of doing it. So I thought I would show you an alternate way of doing this. And so we're interested in a strong acid and a strong base. And so what happens here is we're told a titration is carried out for 25.00 millilitres of a 0.100 molar HCl solution, which is of course a strong acid, and we're going to titrate it against a strong base, a 0.10 molar solution of a strong base sodium hydroxide. And it says that the titration curve is in figure 14.18, and we're asked to calculate the pH at these volumes of added base solution. And so this is the answer that you see worked in your textbook, and I'm going to do it in a slightly different way. And so if we look at the titration initially, we can see that this is a titration of a strong acid. So we would expect at the beginning the pH to be very, very low, which it is, pH of 1. And then as we progressively add sodium hydroxide, which is a base, the pH is going to slowly increase until we get to the equivalence point where it's going to rocket up, and the pH is then going to be very, very high because this is going to be predominantly all base. So at the very beginning of this reaction, when there's 0 volume of sodium hydroxide added, it's all acid in here. And so here it looks like the pH is about 1. And so the first question we're asked is, well, if there's 0 mil of base added, what is the pH? And so if we look at this, if we add 0 mils of base, there's no base added. And so the solution is just this HCl, this 0.100 molar HCl solution. And because we know it's a strong acid will completely dissociate to produce hydronium ion. And because it completely dissociates, the concentration of hydronium ion is going to be equal to the concentration of HCl, because it's a 1-to-1 relationship. So the concentration of hydronium ion is going to be 0.100 molar H3O plus. And then of course pH is minus log times the minus log of the concentration of hydronium ion, which is minus log of 0.100, so the pH is going to be 1.00, which is exactly what we see actually on the curve here. And if you look in the textbook, they do the same, they give you the same answer, which is fabulous. And so the second question is, what happens when we add 12.5 millilitres of base? And if we look here, if we add 12.5 millilitres of base, we could read it off this chart here, and we would see that the pH is going to be around about 1.5. So let's see how we would go about answering this particular question. So on to part B. We're going to add 12.50 millilitres of sodium hydroxide. And so the good thing to do is to write down what reaction is actually occurring. And it's a neutralization reaction. We have hydrochloric acid in the flask. We're adding sodium hydroxide. This is a neutralization reaction. An acid plus a base is going to give us salt and water. And so what we can hopefully see is that there's a 1-to-1 relationship between the acid and the base, because this is a monoprotic acid and this is a strong base. And so how much HCl do we have? Well, the number of moles of HCl we can calculate. We're told that we have 25 mils of a 0.11 molar solution of HCl, and by doing this we can use the constant, the molar solution is going to be the number of moles of HCl divided by volume, Of course, this volume is in millilitres, so we need to convert it to litres by using a conversion factor. These millilitres cancel out, and we end up with moles over litres. Now what we're going to do is to rearrange this to find x moles of HCl. So x moles of HCl is going to be equal to 0.1 molar times 25 millilitres times this conversion factor. And I realise I'm going a bit faster here, but this algebra hopefully will work out. And then the moles of HCl that we have are 0.0025 moles of HCl, which is what we have in our flask. And then we add 12.5 millilitres of this 0.1 molar solution of sodium hydroxide. And so we need to know how many moles of sodium hydroxide we added, because there's a one-to-one relationship. And so here we know the concentration of sodium hydroxide is Y. In this case, I'm just using Y, moles of sodium hydroxide divided by the 12.5 millilitres times, of course, this conversion factor to make it into litres. And we're going to rearrange it just like we did up here, and we're going to calculate that the number of moles of sodium hydroxide is 0.00125 moles of sodium hydroxide, and that's how much we've added to the HCl. So if we go back to looking at this equation, we started out with 0.0025 moles of HCl up here. We added some sodium hydroxide here, and this amount is going to react in a one-to-one relationship. And the amount of sodium hydroxide that we have is less than the stoichiometric amount of acid. So if this amount was 0.0025 moles of sodium hydroxide, it would completely neutralize the acid. We would end up with a neutral solution, which of course would have a pH of 7, but which is going to be the next question anyway. So because the amount of acid is less, it will be completely consumed by the acid. And so some acid is going to remain, because this is a smaller amount than this. And so we need to know how much acid remains. So as the reaction is 1 mole of HCl reacts with 1 mole of sodium hydroxide, we can say that the amount of acid that's remaining is the amount of acid that we started with, and then this acid reacted with this much sodium hydroxide, which is what it reacted with, and so the amount of acid that's left over is the initial amount of acid minus that which reacted with the sodium hydroxide when it reacted in a 1-to-1 ratio. And so we can subtract these values, and we realise that at the end we have 0.00125 moles of HCl remaining in the flask, because it reacted with all of the sodium hydroxide. And so at this point now we need to determine the concentration of this HCl that's left. And so we know the number of moles of HCl. We need to know something about the volume, because concentration is moles divided by volume. Well, the most important thing to realise is, what is the volume? Well, we started with 25 millilitres of acid in the flask. We added 12.5 millilitres when we added this base solution. So the new volume is 37.50 millilitres. It's more than it was before because we added some solution. So the concentration of HCl is the number of moles of HCl, which we calculated up here, divided by the total volume that's in the flask, which is 37.50 millilitres. Then, of course, we have to convert it to litres. And when we do this, we end up with a concentration of HCl of 0.033 molar. Now, of course, we're looking for the pH. And so, as we know that HCl is a strong acid, it's going to completely dissociate. We know that HCl is going to completely dissociate to H3O+, so the concentration of HCl is the same as the concentration of H3O+. Therefore, the concentration of H3O+ is 0.0333 molar. And therefore, the pH is going to be minus the log of that concentration, and the pH comes out to be 1.48, which is the final answer. And so we had to take into account the volume. And so actually, if we look at this plot, we added 12.5 millilitres of sodium hydroxide, and indeed the pH is about 1.5, or in this case, because we calculated it, 1.48. And so this is an alternate way of going about this particular problem. And so after this problem, if I go back to the beginning, this problem asked, what if you add 0 mils, 12.5, 25 mils, 37.5 mils? They show one method with a large equation. I've shown you a method by breaking it down into what we've seen before. And so if you go to your textbook, you can also do the next two, C and D, and understand how a titration of a strong acid and a strong base works, and how you can calculate the pH of the solution at all of these points.